Hi there, we're going to be doing a comparison of two means. We're going to look at gender and see whether males or females spend more time eating or drinking. Assumptions going into this, we're going to assume that all observations within each group will be independent from one another, and all observations between each group will be independent of one another. The data we're going to use is the time use data frame. The first variable, which is numeric, will be minutes spent eating and drinking per week. And the second variable will be categorical, and it will be gender, male or female. Keep in mind, R organizes things alphabetically, so female data will pop up first when you run these. I loaded library ggplot2 and the EDA just so I didn't have to do later when we did graphs, just so it would already be there. Go ahead and run that. Numerical data, you can run these three commands to get the mean, the standard deviation, and the length or number of observations per each group. It's a tapply function. We'll see the mean is lesser for females as well as standard deviation. Those will become a little bit more important later on. I also just ran the normality test and the Bartlett test because I organized it by numerical EDA and visual EDA, but you could run it after you run graphs. But for the Shapiro test, keep in mind that if you just run it straight up, there's too many observations, so you have to take a sample of your current sample size and keep it within 5,000 in order to run this test successfully. And you can see that for both females and for males that the p-value is incredibly low, which suggests that we're not going to have a normal distribution, and we'll see that later on in the graphs. Running the Bartlett test to test for equal spread or constant variance. We also see that we get a very small p-value, which means it's probably not going to have constant variance or equal spread. That'll be important when we run our t-test later on. But visually, I used qplot to run both side-by-side histograms and side-by-side density estimates. It might take a little bit long for R to load, but don't just ignore these bin width warnings. It's just saying you might get a more accurate answer if you picked a better bin width, but it still captures the values perfectly fine. So this is the overlying density estimate. You can see they're pretty similar. There's a skewness right, but as far as where they're dense, it's pretty similar between male and female. You can see the same graph side by side if you wanted to make it a little clearer. You can also see an overlying histogram. You can see same thing, kind of more dense in the same spots, but similar tails on the right side. There's more observations for females, so that might be why there's a higher observation here. And we saw that with the length function. You can see it side by side again. Look pretty similar. The males seem to be a little bit more dense in a concentrated area than the females. Females are a tiny bit more spread out. You can also run a box plot and see where the outliers are. You can see there's a lot of outliers on the right on both sides and kind of how skewed it is. They're both skewed right, but the mean for female seems a little bit more to the left, a little bit less than the male. You can also get a lot of data in the box out function. So looking at the summary of all this, we can see the standard deviation for males is higher than for females by about 4 deviations. Histograms, density estimates, along with our normality test here, kind of give us proof that there's not a normal distribution among both the means. Box plots will show outliers to the right and skewedness that we already saw. And completing the Bartlett test, we can conclude there's not constant variance, which is important when you come down here to the t-test because running this test, the default is that there is not constant variance, but you could still change that or type var.equal equals false. But you don't have to since it's already the default. But if we run this test, we'll get some data over here showing a small p-value, showing that, again, the mean is less in the female group than the male group, which will suggest that males spent more time eating and drinking. And by about how much, we have this confidence interval right here. So we are about 95% confident that the difference between the mean time in minutes spent eating and drinking among females compared to males is between the interval of -7.43 and -5.704. Since the entire interval is less than 0, it can be concluded that the mean time spent eating and drinking by females is less than the time spent by males. All right, thank you.